Everyone, and this is Sandeep. You are watching Samyans Academy, and in this session, we are going to discuss about current electricity part 2. Let us start now. And in previous class, we discussed about Ohm's law. So let us discuss briefly about this Ohm's law. When voltage increases, current also increases. When voltage decreases, current also decreases. Then voltage is directly proportional to current, right? So V is directly proportional to I. Then V by I equal to R. Then V equal to IR. So what is R? R is a resistance. R is a constant for the given metallic wire at given temperature, and also it is called as resistance, and it is the property of a conductor to resist the flow of charges through it. Okay, every conductor has some resistance, right? Because of this, the conductors oppose the flow of electric charge through it, and this property of particular conductor, particular substance, we called as resistance, and this we indicated with the R. Yes or no? And now, units of resistance is ohm. So we represented with the Greek letter like this is a ohm, right? What is R? V equal to IR, then R equal to V by I. Then what are the unit? What is the unit of resistance? Unit of resistance is ohm. Then how do you define the 1 ohm? So 1 ohm we can define like this. So let us say this is a 1 ohm, and V means it is equal to 1 volt, and I is 1 ampere. Okay, by seeing this, we can define the 1 ohm. What is 1 ohm? If the potential difference across the two ends of the conductor is 1 volt, okay, this is a 1 volt. It is a potential difference between the two ends of the conductor. Let us say here we have one resistor, right? So here we have one resistor. Okay, suppose the potential difference between the two ends of a conductor is 1 volt, means the potential difference between the A and B, let us say this is 1 volt, and the current through it is 1 ampere. Suppose the current flows through it is a 1 ampere, then the resistance are said to be 1 ohm. Okay, is it clear everyone? The potential difference between across the two ends of the conductor is 1 volt, and current through it is 1 ampere, then the resistance R of the conductor is how much? 1 ohm. So 1 ohm we can define as 1 volt by 1 ampere. Is it clear everyone? Okay, to understand the resistance, here we are performing one activity. So in this activity, so we observe that current is different for the different components. Okay, if you take the copper and aluminum, and if you take the wood, the current flow of electric current is depends on the substance, and it depends on material to material, it will vary. Okay, certain components offer an easy path for the flow of electric current, while others resist the flow. For example, you take aluminum, silver, and through this, and these are the metallic conductors, it can allow the electric current through it very easily. Means the flow of electrons pass through these conductors are very smooth and very easily. Some conductors are there like it is not conductor. Let us say that they are insulators. Okay, from through insulator, the flow of electric current resist by the some atoms, and this is a property of that particular material, and also we called as a resistance, right? And every material has some resistive property, and it depends on metal to metal, and substance to substance, and conductor to conductor, and it depends on insulator. And insulator means which do not allow the electric current through it, we called as an insulator. Okay, to perform this activity, we are taking these different types of the material, and we are checking that which is giving more resistance value and which is not giving the more resistance value, that is acts as a good conductor. Now you see, we know that motion of electrons in an electric circuit constitutes an electric current. Because of flow of electrons, the electric current is flows through the conductor. The electrons, however, are not completely free to move within a conductor. They are restrained by the attraction of the atoms among which they move. For example, when you take any conductor like this, right? So when you take the any conductor, right? Let us assume this is the copper conductor. It has some copper material, yes or no? Copper atoms. Okay. Let us assume that the electrons are flowing like this. Electrons are flowing between these. It has to flow like this electron, and these electrons are restrained by this copper atom. Okay, because of this, when you move in the traffic, then what happens? Your speed reduces to somewhat, right? Here also, when electron is moving in this direction, here there are some atoms are there. Because of these atoms, and this atom attracts the electrons, because of the flow of electrons somewhat it reduced. Okay, due to this, and electrons are resisted by these atoms. Okay, and this leads to resistance of particular material. Now you see the electrons, however, are not completely free to move within a conductor, and they are restrained by the attraction of the atoms, okay, among which they move. Suppose they are moving, electrons are moving among the copper atoms. Then what happens? This copper atom attracts some electrons. Due to that, the flow of the speed of the electrons reduced. Okay, and this leads to resistance. Thus, motion of electrons through a conductor is retarded by its resistance, and this property of the particular material we called as resistance. Yes or no? And thus, motion of electrons through a conductor is retarded. A component of given size that offers a low resistance is called as a good conductor. Okay, so which acts as a good conductor, and which gives the only low resistance value, that one will act as good conductor, and it can allow the flow of electrons through it very easily. Okay, they act as a good conductor. Example for the good conductors are metals, right? Silver, copper, aluminum, and these all acts as good conductors, and the resistance value of these conductors are very low. Okay, and which one is acts as poor conductor? A conductor having appreciable resistance and is called as resistor. Every conductor has some appreciable value of resistance, and that value is we called as resistor, right? And which one we called as a poor conductor? A component of identical size that offers a higher resistance is called as poor conductor, and insulator of the same size offer even higher resistance. Okay, poor conductor means which has high resistance value acts as a poor conductor, and which has very high resistance that acts as a insulator. Okay, so materials depending upon their resistive value, materials are depends on how many types? Three types. One is good conductor, second poor conductor, and third one is insulator. Good conductor has low resistance value, poor conductor has a higher resistance value, and insulator has even higher resistance value. Means they do not allow the flow of electric current through it. They completely stop the flow of electrons. Okay, and such type of materials we called as insulators. Okay, and this is the activity 12.2. Now you see what are the factors which affects on the resistance of a conductor depends. Mainly, resistance of a conductor depends on three things. One is length. When resistance, when length increases, when length of the conductor increases, then resistance value also increases. Then, if area increases, resistance value decreases, and resistance value depends on nature of the material also. And these three things which affect the resistance depends on what are the three factors. One is length, other one is area, and third one is nature of the material. How that resistance depends on length? When resistance length increases, suppose length increases, resistance value also increases. Suppose let us assume if you travel for more distance, then what will happen? You will get tired, but that means your motion will somewhat reduce. For example, here also, when length of the conductor increases, then resistance value also increases. Okay, the electrons resisted by if they move more distance, means they're restrained by somewhat, means the flow of charge somewhat it is reduced. Okay, then that leads to more in resistance, right? If flow of electrons decreases, resistance increases, and this is vary with the length. When length increases, resistance value also increases, and resistance is inversely proportional to cross section area of the conductor. Let us say I'm taking here two types of conductors, and this is having the less area, assume that, and it is having more area. Suppose, let us assume you are moving in a narrow road, then what is your speed will be? And same, you are moving in the highway, what is your speed will be? Yes, already you know that if you are moving in the highway, our speed increases, right? When you are moving in highway roads, then what happens? Your speed automatically it will increase. Why? Because there is a lot of space. Okay, and there is no other atom, there is no traffic, and zero traffic is there. The road is wide, we can move very fast. Means the material which is having more in area, in that the flow of electron moves very fast. Okay, electrons moves very fastly through this conductor. Why? Because the area is more here. Wherever the area is more, the flow of electrons, the speed of electrons is fast, whereas the resistance value decreases. Is it correct? Now you see, when area increases, resistance decreases. Why? Because the electrons moves very fast. Okay, the electrons moves very fast means resistance value is very low. For example, you are moving in narrow road. The road condition is also not good. In that condition, your vehicle speed somewhat reduced. Yes or no? Means the speed of electron is reduced, means here in this conductor the resistance is more. If area is less, electrons cannot move freely. Why? Because the area is very less, they cannot move freely, they are restrained by the road condition. Means if you are moving in when you are moving in the road which is in not good condition, in that case your speed reduced or not. In the same way, if area is less, electrons the speed of electrons reduce and the resistance value will more in this case. Is it clear? If when area increases, the speed of electrons increases, resistance decreases. Means area is increasing, resistance value is decreasing. What is the relation? Resistance is inversely proportional to cross section area of the conductor. And when you combine these two, you will get resistance is proportional to L by A. When you remove this proportionality, you have to put one proportionality constant. What is that? R equal to rho into L by A. Okay. And what is that rho? And rho we call as constant proportionality and also is called as electrical resistivity of the material of the conductor. Every conductor has some resistivity value, okay, based on speed of electrons through it, right? And what are the SI unit of resistivity? How do you calculate this resistivity units? Now you see, already you know the formula of resistance. Resistance equal to rho into L by A, right? So when you rearrange this, you will get like this: rho equal to RA by L. Already you know that the resistance units of resistance is ohm, okay, and area. What is the unit of area? Yes, that is meter square, ohm meter square by what is the unit of length? That is meter. Okay, when you cancel this meter, then what will you get here? Ohm meter, and this is the unit of resistivity which is equal to ohm into meter. Okay, units of resistivity is ohm meter. Ohm we represented with this symbol, so we can represent like this also. Okay, this is a unit of resistivity. Remember, this is very important and it is a characteristic property of the material. Okay, every material has some resistivity value. Let us say here we have one table. Okay, so here we have one table. Now you see, and these are the resistivity values of some materials. Now you see, here we have the silver, copper, aluminum, tungsten, nickel, iron, chromium, mercury, manganese, and these are the materials, and they act as a good conductor, have low resistivity value, 1.6 into 10 power minus 8. Okay, the material or the metal which has a low resistivity value, it acts as a good conductor. Okay, now you see, among all these conductors, which one is acts as a good conductor? Yes, which one has low resistivity value, that one acts as a good conductor. Yes or no? Now you see, silver, copper, aluminum, tungsten, nickel, iron, chromium, mercury, manganese there, and among all these conductors, silver has low resistivity value, which is equal to 1.6 into 10 to the power of minus 8 ohm meter, means it acts as a good conductor, whereas the remaining has the resistivity value increases 1, 2, 5, 6, 10, 12, 94, like that, but it is 10 power minus 6 is there. Okay, that means here 184, that we can assume as it is 184 into 10 power minus 8. Yes or no? Means the resistivity values increases, right? The conductivity nature decreases. Means among all these elements, which acts as a good conductor, which has the low resistivity value, that one acts as a good conductor. Okay, and silver acts as a good conductor. Yes or no? Now when you come to the alloys is made with the more than 2 or 3 metals. Okay, when you mix the more than 2 or 3 metals, it will form alloys. And when you see about the constant and alloy, this alloy is made with the copper and the nickel. Okay, now you see, when you see the copper, what is the value of copper resistivity value? 1.62 into 10 power minus 8. Now you see, when you this copper is mixed with another metal, the resistivity value is increases. Okay, suddenly increases. And you see, this is a 1.6 into 10 power minus 8, and it is 44 into 10 power minus 8. almost it is increases to 100 times. Okay, means when metal mixed with another metal, it will give alloys, and this alloys has more resistivity value. So due to this more resistivity value, and it acts as a heating, it acts as good heating element. The materials which has high resistivity value and which acts as heating device, which acts as good heating devices, means heating elements. Okay, when you pass the electric current through these alloys and they get heated up. Okay, because of this nature, these alloys are used in heating devices like electric geysers, rice cookers, and what are the heating elements are there? Can you give the examples? Electric heater and geysers, room heaters and toasters and microwave ovens, and all in these devices, and these alloys used as heating devices. Okay, heating elements. Okay, now manganese is there, alloy of copper, manganese and nickel, and this nichrome alloy is used in electric iron boxes. Okay, and this is used as a what is that, coil. This nichrome wire is made with a nichrome material is made with nickel, chromium, manganese and iron. It has high resistive value. Because of this, it acts as a good heating element, and which is used in electric iron boxes. Now you see, and some elements has more resistivity value. Now you see this is a 10 power minus 8, 10 power minus 6 is there. When you comes to the insulator, the glass has more resistivity value. It is not minus value, it is a plus value, 10 to 10 to the power of 14. It is very high value, and it acts as insulator. They do not allow the flow of electric current through it. Completely it is zero. Okay, they do not allow the electric charge through it. Okay, glass, hard rubber, ebonite, diamond, paper, and these all are having the more resistivity value, means it acts as a insulator. Okay, based on the resistivity value, then materials classified into how many types? Two types: conductors, alloys and insulators. Conductors has low resistivity. Conductors have low resistivity value compared to the alloys. Alloys is made with more than two or more metals, and the resistivity value of individual metal is more than the alloys, right? No. Alloys has more resistivity value than individual materials. Like when you see the copper has very low resistivity value. When copper is mixed with the another metal, then resistivity value increases to 100 times. Okay, alloys has more resistivity value. So because of this, they act as heating elements, and they are used in heating devices such as electric iron, electric geysers, toasters. Okay, all in electric devices, heating devices, and these alloys used as a coil, heating elements, right? Nichrome used in electric iron boxes. Manganese, copper, manganese, manganese made with the copper, manganese, and nickel. It has a resistive value 44 into 10 power minus 6, and constantan has 49 into 10 power minus 6, and nichrome has a resistive value 100 into 10 power minus 6. Okay, now, whereas in case of insulator, the resistive value increases suddenly. So it is a positive value, 10 to 10 power 14, means it is a very high resistance value. And they do not allow the flow of electric current through it completely. Okay. And this is about the uh, electrical resistivity of substance at 20 degrees Celsius. When you increase the temperature, the value may be vary, because this resistivity depends on temperature, right? Remember this. And the metals and alloys have very low resistivity in the range of 10 power minus 8 ohm meter to 10 power minus 6 ohm meter. So they are good conductors of electricity. Whereas insulator like rubbers and glass have resistivity of the order of 10 power 12 to 10 power 17 ohm meter. Both the resistance and resistivity of material vary with the temperature. Okay, remember, it's a very important one. In your exam, they will ask like this. So suppose when you increase the length or decrease the area, then how the resistance and resistive values varies. Remember, resistance depends on length and area, but resistivity does not depend on length and area. Resistivity is always constant for a particular material. Resistivity depends on only temperature. Okay, for example, if length of the wire increases to two times, area of the conductor decreases to two times, then how the resistance will vary, like that they will ask. How the resistivity value also vary. Remember, resistivity do not depend on length and area. Resistivity is always constant for a particular material. Okay, and resistivity depends on only temperature. Both resistance and resistance value vary with the temperature, but resistivity value is always constant. They do not depend on dimension of the material. Wherever the length increases or area decreases, whatever it may be, the resistivity is always constant. The rho value is always constant for a particular material, but resistance value depends on length, area. Remember, it's a very important point. Both the resistance and resistivity of a material vary with the temperature. Now you see, the resistivity of an alloy is generally higher than that of its constituent metals. Already we discussed now. So because of these reasons, the alloy do not oxidize readily at higher temperature. That means they do not get burned even at higher temperatures, right? So for this reason, they are commonly used in electrical heating devices like electric iron toaster, electric geysers, etc. Okay. Now here we have tungsten fire. Tungsten. Already you know that the tungsten filament. Already you listen this word. This tungsten is used almost exclusively for filaments for in bulbs, right? Whereas copper and aluminum are generally used for the electrical transmission lines. Okay, and in electrical transmission lines, copper and aluminum wire are used, right? Copper and aluminum are generally used for the electrical transmission lines, whereas tungsten is used almost exclusively for filaments of electric bulbs. Okay.